think you understand time. You wear a watch, you feel yourself getting older, you remember yesterday, and you plan for tomorrow. Time seems obvious. It seems like the most natural thing in the world. But that is not time. That is just a sensation, a biological trick your brain plays on you to keep you from experiencing everything all at once. If you want the truth, the raw mechanical truth that Richard Feynman and Albert Einstein uncovered, you have to be willing to throw away your common sense. We are about to deconstruct every pillar of your reality. If you are looking for quick entertainment, this isn't for you. But if you are looking for the engineering behind the cosmos, you are in the right place. Subscribe to the channel, because the journey we are starting now is a one-way trip into the deep structure of the universe. For centuries, humanity lived under the protective shadow of Isaac Newton. To Newton, time was like a divine stage, a master clock ticking at the heart of the universe, dictating the rhythm for everything in existence. It didn't matter if you were a peasant in England or a star in a distant galaxy. A second was a second for everyone. This was absolute time. It was comforting because it gave order to the chaos. It created a universal now. But there was a problem. Newton couldn't explain what that clock actually was. He just assumed it existed, and that is where physics began to crack. Imagine you are in a perfectly dark room. No sound, no light, no change. Does time still pass? Newton would say yes. Modern physics says no. Without change, time loses its meaning. It isn't the stage, it is the play itself. If this distinction between the wall clock and the dance of atoms makes your head spin, leave a like. It helps bring this discussion to more people trapped in the Newtonian illusion. The great crisis came with light. James Clerk Maxwell discovered that light has a fixed speed, 300,000 kilometers per second. But speed relative to what? If I run after a car at 20 miles per hour and the car is going 30, I see it move away at only 10. But with light, that doesn't work. If you run after a beam of light at nearly its own speed, you will still see the light move away from you at 300,000 kilometers per second. The universe imposes a speed limit, and for the speed of light to remain the same for everyone, something has to be sacrificed. That sacrifice is your precious time. It needs to stretch and shrink so that light can remain constant. Time stopped being a sovereign judge and became a rubber band. Let's go back inside your head. Feynman loved testing the limits of the human machine. He conducted a famous experiment on how we count time. Try to count 60 seconds right now. 1, 2, 3. If you use your internal voice, you are using your left prefrontal cortex. If I ask you to read a news story while counting, you will fail. Why? Because reading and counting with an internal voice use the same neural road. But some people don't count with a voice. They visualize a measuring tape. They see the numbers passing by. These people can read, talk, and even solve problems while their visual clock keeps ticking with precision. What does this prove? It proves that your time is a subjective process, a piece of software running on biological hardware. There is no universal sense of time. What you feel is just your brain organizing memories in a line. You think you live in the present? I hate to disappoint you, but you live in the past. Light signals take time to reach your eyes. Chemical processing in your nerves takes milliseconds. By the time your brain finally assembles the image of what you are seeing now, that event is already over. You are always watching a replay. If you look at the moon, you see it as it was a second ago. If you look at the sun, you see it as it was 8 minutes ago. If you look at the stars, you are looking at light ghosts from millions of years ago. The now is a local convenience. There is no now that covers the entire universe. If an alien in a distant galaxy starts walking away from Earth right now, their now might be slicing through time on Earth in the year 1700. Time is a perspective, like depth. What is near to me might be far to you. Comment below. Have you ever felt time stop in a moment of shock? That was your brain stopping its edit of the film of reality. Imagine you are holding an apple and you let go. It falls. To you, it's gravity pulling the fruit to the ground. But for the physics that governs time, what is happening is much stranger. The mass of the Earth is so great that it is literally crushing the time around it. Think of time as a fluid that gets thicker and slower near heavy objects. This means that if you put a clock on top of Everest and another by the sea, the clock on the beach will tick slower. Your feet are mathematically fractions of a nanosecond younger than your head because they are more deeply immersed in the temporal curvature of the Earth. This leads us to one of the greatest shocks to human intelligence, the twin paradox. Imagine you have a twin brother. You stay on Earth and he enters a ship traveling at 99% the speed of light. To him, inside the ship, everything seems normal. He makes coffee, reads a book, sleeps, and wakes up feeling that time is passing as it always has. But when he returns after what he felt was only a year, he finds you as an old man, or perhaps he finds only your grave. What happened? He didn't travel to the future like in science fiction movies. He simply traveled a shorter path through the fourth dimension. His time wasn't just measured differently, it was lived differently. Time is a currency, and if you spend all that currency moving through space, there is nothing left for you to age. Every atom in your body is a tiny clock. Every vibration of an electron is a tick. When you move fast, those vibrations slow down. It isn't just that your watch is broken, it is that your very biology is slowing its rhythm relative to the rest of the world. This has been proven with atomic clocks on jet planes. We have seen it. We have measured it. The universe does not care if it feels wrong to you. Now, we must face the darkest mystery of physics. If the equations governing atoms work perfectly both forward and backward, why do you never see spilled coffee jump back into the cup? Why do we remember the past and not the future? The answer is not in time, but in chaos. Imagine you have a puzzle assembled inside a box. If you shake the box, the pieces get messy. If you shake it again, they get even messier. The probability of you shaking the box and the pieces joining together on their own to form the original image is practically zero. This is entropy. The universe started in a state of absolute order at the Big Bang. The puzzle was assembled. Since then, time is just the name we give to the process of shuffling those pieces. The arrow of time is not a property of time itself, but a consequence of our own ignorance and the universe's tendency toward messiness. We only feel time passing because the universe is getting uglier, more spread out, and colder. On the day the last star goes out and the last atom stops vibrating, entropy will be at its maximum. At that moment, time will cease to exist. Without change, there is no before or after. We then come to the inevitable conclusion that has haunted physicists for decades: the block universe. If time is a physical dimension, like the width of a room, then the past has not died, and the future is not being born. They are all there, simultaneously. The moment you were born and the moment you are listening to my voice now are all fixed points in an eternal four-dimensional block. Your perception that the now is special is just a limitation of your consciousness, like a flashlight in a dark tunnel that only illuminates 1 meter ahead. But the entire tunnel exists, even in the parts where the light doesn't reach. Think about a movie reel. When you watch the film, you see the characters move, laugh, and cry. You see the story unfold from start to finish. But if you hold the entire reel in your hand, you can see every frame at once. The beginning of the movie and the end of the movie are both physically present in your hand. The universe is that reel. Feynman used to say that we shouldn't feel bad for not understanding these things intuitively, because nobody does. We just get used to the equations. Time is the greatest magic trick in the universe. It gives us the illusion of choice, the illusion of movement, and the sweet illusion that we have a today. But deep down, we are just patterns of energy floating in an eternal and immutable structure. We build these mental models, these counting machines, because we need to survive. We evolved to track duration, but we did not evolve to understand the dimension of time. Our brains are efficient, not accurate. We focus on the now, because that's where we live. But in physics, now is a very slippery concept. When we try to teach you about the curvature of space-time or the quantum nature of reality, we aren't just giving you new facts. We are asking you to delete your operating system. We are asking you to throw away the tape measure and silence the voice. And that's why it feels so hard. That's why your brain rejects it. You aren't just learning, you are translating against the grain of your own biology. Even the word time is a linguistic trap. We say time passes, but where does it go? We say time flies, but what are its wings? We are using the language of birds and rivers to describe the geometry of the infinite. Consider the GPS satellites orbiting our planet right now. They are moving fast, which means their time slows down due to velocity. But they are also far from the Earth's mass, which means their time speeds up because gravity is weaker up there. These two effects fight each other. If we didn't use Einstein's equations to correct their clocks every single day, the GPS on your phone would be wrong by 10 kilometers within 24 hours. General and special relativity are not just ideas in a textbook, they are holding your modern world together. But there is a final question. If time is a dimension and every moment is already there in the block, do we have free will? If your tomorrow is already a fixed frame in the movie reel, are you just an actor following a script you didn't write? This is where physics meets the soul. Some say that even if the path is fixed, the experience of walking it is ours. Others say that quantum mechanics introduces a randomness that even the block universe cannot predict. We are at the edge of what we know. If you've made it this far, subscribe to the channel. The journey to understand what we are has only just begun, and I guarantee the truth is much deeper than any clock can mark. Comment below. Do you prefer the lie of the flowing river or the truth of the block that remains? The choice, ironically, is yours. Look at the stars tonight and remember, you aren't looking up at the sky, you are looking back into the history of the world. You are a time traveler just by opening your eyes. Stay curious, stay restless, and never trust your watch again. Expanso Massiva, Parte 2. Let's dive deeper into the mechanics of this bending of time. To understand how gravity crushes time, you have to imagine space and time as a single fabric, what we call space-time. Newton thought they were separate. He thought space was the stage and time was the ticking clock on the wall. Einstein realized they are interwoven. If you put a heavy object on a trampoline, like a bowling ball, it creates a dip. A smaller ball, like a marble, will roll toward that dip. That's what gravity is. But Einstein's genius was realizing that the bowling ball doesn't just bend the fabric of space, it also bends the speed of the clock. Imagine you are standing on the surface of a star. The gravity is immense. Because the fabric of space-time is so stretched and distorted, your ticks take longer to happen relative to someone standing in empty space. This is not a trick. It is a physical reality. If we could build a skyscraper tall enough that its base was on Earth and its top was in deep space, and you had a twin brother at each end, the twin at the bottom would literally be living in a slower moving reality than the twin at the top. This is called gravitational time dilation. It is the reason why black holes are so fascinating. At the event horizon of a black hole, the gravity is so strong that the dip in the trampoline becomes infinitely deep. Time, as we understand it, simply stops. If you watch someone fall into a black hole, you would see them slow down, and eventually freeze forever at the edge, turning redder and redder until they vanish. From their perspective, they fell in instantly. But from yours, they are suspended in time for eternity. How can two people see the same event so differently? This brings us to the core of Feynman's philosophy. Nature doesn't care about our intuition. Our intuition was built to find fruit and avoid tigers on the African savanna. It wasn't built to understand the edge of a singularity. When we talk about these things, we have to rely on the language of mathematics, because our own tongues fail us. Now consider the arrow of time again. We talked about entropy, the tendency of things to get messy, but why did the universe start so tidy? Why was the Big Bang such a state of low entropy? This is one of the biggest unanswered questions in all of science. If the universe started in a mess, we wouldn't have time as we know it. We wouldn't have life, because life requires a flow of energy from order to disorder. You are, in a sense, a machine that converts order into chaos. You eat organized food, proteins, carbohydrates, and you turn them into heat and simpler molecules. You are a localized pocket of order fueled by the destruction of order around you. When you die, your body's entropy increases. You stop maintaining the complex arrangement of cells and atoms. You dissolve back into the messiness of the earth. This is why we associate time with decay. But remember the block universe. Even though your body decays in the future frames of the movie reel, the past frames where you are alive, breathing, and thinking are still there. They are as real as the chair you are sitting on. They don't disappear just because the flashlight of your consciousness moved past them. This is the profound comfort of physics. Nothing is ever truly lost. Think about the way we measure a year. One trip around the sun. But the sun itself is moving through the galaxy. The galaxy is moving through the cluster. There is no center to the universe, so there is no stationary point to measure against. This means your speed is always relative. If you are sitting still right now, you are actually moving at thousands of miles per hour through space. And because you are moving, your time is already being dilated relative to something else. There is no true time. There is only your time and my time. We spend our lives trying to save time, kill time, and manage time. But you cannot manage a dimension. You don't try to manage the length of your hallway or the height of your ceiling. You simply navigate them. We need to start looking at time the same way. It is a territory to be explored, not a resource to be spent. If you can accept that every moment of your life is an eternal landmark in the four-dimensional geometry of the cosmos, then the fear of running out of time starts to fade. You aren't running out of anything. You are just reaching the edge of your particular path through the block. Feynman often spoke about the pleasure of finding things out. The pleasure isn't in having the answer, it's in the struggle to understand the machine. And the machine of time is the most complex one we've ever found. It links the smallest subatomic particles to the largest galaxies. It links the beginning of the universe to its inevitable cold end. If this deep dive into the guts of reality has stirred something in you, then my mission is accomplished. We aren't here to give you easy answers. We are here to show you how beautiful the questions are. Subscribe, share, and keep questioning. Because in a universe where time is an illusion, the only thing that is truly real is your curiosity.